The hidden foundation of modern defence logistics. In modern defence logistics, we often focus on inventory levels, forecasting accuracy, supplier resilience, and platform availability. But underneath all of that sits something much more basic and often much more overlooked. That is the physical data of the items we are trying to move, store, deploy, and sustain. If we do not know the true dimensions, cube, weight, and packaging profile of our inventory, then we are trying to optimize the supply chain without understanding the physical reality of what is flowing through it. This presentation is about why volumetric data is not just an administrative detail, it is foundational operational intelligence. Volumetric data matters because logistics is a physical system. Every item has a size, a shape, a weight, a handling requirement, and a packaging profile. Those characteristics affect how the item moves through the supply chain. They influence transport planning, warehouse design, storage capacity, operational outload, automation, sustainability, and even readiness. The problem is that many organizations know what an item is, where it is, and how many they have, but they may not know how much space it takes up, how it is packed, whether it can be stacked, or how easily it can be handled. That gap matters because without good physical data, logistics planning becomes assumption-led rather than evidence-led. When we talk about volumetric data, we are not just talking about length, width, and height. That is part of it, but the full picture is broader. We need to understand the item's cube, actual weight, dimensional weight, packaging configuration, stackability, handling constraints, and palletization. We also need to know whether the item has environmental storage requirements, hazardous classification, load orientation restrictions, or special movement conditions. These details may sound small, but they are what determine whether the item can be stored efficiently, moved safely, picked accurately, and deployed at speed. In short, volumetric data tells us how material behaves in the real world. Historically, many defence organisations have been very good at managing inventory records. They know the stock number, the description, the quantity, the value, and sometimes the owner. But modern logistics requires more than inventory administration. It requires supply chain engineering. That means understanding flow, throughput, network capacity, transport utilization, warehouse layout, automation, and operational deployment. A supply chain cannot be properly engineered if we do not understand the physical characteristics of the material moving through it. The shift is from simply asking, what do we own, to asking, how does it move, where does it fit, and how quickly can it support operational output. One of the most common mistakes in logistics is thinking in item counts rather than physical footprint. 10,000 items might fit on one shelf, or they might fill an entire warehouse. Without volumetric data, we cannot properly understand storage burden, rack utilization, aisle requirements, handling equipment needs, or future infrastructure demand. This becomes especially important when planning surge operations, war reserve holdings, or strategic stockpiles. It is not enough to know that we need 30, 60, or 90 days of stock. We also need to know where that stock will physically sit, how it will be handled, and how quickly it can be moved. Capacity planning starts with cube. Operational outload is where volumetric accuracy becomes directly linked to operational effect. If we are deploying a force, we need to know how many trucks, aircraft, containers, ships, or pallets are required. We need to know what creates the bottleneck. Is it weight, cube, handling equipment, loading time, infrastructure at the receiving end? Without accurate volumetric data, planners are forced to use broad assumptions. That can lead to underutilised lift, too many vehicle movements, slower deployment timelines, and increased operational risk. In defence, poor logistics efficiency is not just a cost issue. It can affect survivability, tempo, and readiness. A good example of this is submarine support. Submarines operate in one of the most capacity-constrained environments in defence. Every cubic metre matters. Onboard storage is limited, access routes are constrained, weight and balance are critical, and internal layouts are carefully engineered. If we do not understand the true packed dimensions of spares, repair assemblies, consumables, and specialist equipment, then it becomes much harder to optimise stowage and sustainment. The risk is that the platform either carries too much just-in-case inventory, reducing space for other critical stores, or carries too little and increases the risk of operational constraint. In a submarine environment, poor volumetric data can quietly become a readiness issue. Transport and warehousing are both heavily dependent on physical data. In transport, volumetric data affects container fill rates, pallet builds, vehicle utilization, route efficiency, and multimodal movement. Vehicles often cube out before they weigh out. That means the available physical space is used up before the weight limit is reached. The result is wasted capacity, unnecessary movements, and increased cost. In warehousing, volumetric data supports slotting, rack design, pick face sizing, automation, robotics, and storage density. Without it, warehouses become inefficient, congested, and harder to operate. Physical data underpins efficient movement and storage. Poor volumetric data also affects day-to-day execution. If item dimensions, packaging and handling requirements are wrong, pick faces may be badly configured. Operators may struggle to identify items. Items may need repacking, rehandling, or relabeling. That increases omissions, mispicks, damage, and delays. This becomes even more important as defense and industry move towards automation, machine vision, barcode validation, robotic handling, and intelligent warehouse systems. Automation depends on clean, structured, and accurate master data. If the physical data is poor, the automation will simply automate the problem. Good volumetric data improves execution as well as planning. The key message is simple. You cannot optimize the flow of material if you do not understand its physical footprint. Volumetric data is not an administrative extra. It is not just something that sits in a master data field. It is operational intelligence. It affects how we store, move, deploy, sustain, and recover capability. For defense, this matters because logistics is not just about holding inventory. It is about getting the right material to the right place in the right condition at the right time under pressure. If we want better readiness, better resilience, and better operational performance, we need to start by understanding the physical reality of the items we manage. Volumetric data is not detail, it is operational advantage.